Mold and algae protection is a really important part of what we specify, and this is particularly relevant to external insulation systems. Now, there's various different ways you can externally insulate a building, and there's a huge housing stock available to us where we have properties that really aren't performing in anywhere near the sort of standard that they need to be, where the really only option of improving that performance is to put external insulation systems on. Typically, and this has happened not just in the UK, but throughout Europe, the processes that they use involve low density expanded polystyrene systems. And they do that because they're the cheapest systems you can buy. EPS is very cheap, and it has a low lambda value. So so where you're really thinking about nothing other than the U value, those materials come into play. But there are obviously implications for using those materials, and you have to sort of take a bit of a holistic approach to the whole fabric to say, well, yes, I'm looking at U value only, but what are the possible consequences of just taking that sort of singular approach? And one of those is the ability of a natural insulation and an insulation with a high density to stop mold and condensation and algae forming on the surface of the wall. The important thing to consider with those sorts of systems is that at some point on all walls, the condensation point, the dew point, so the point at where warm air becomes liquid, occurs on the surface of the material. And when it occurs on the surface of the material, you're essentially creating a habitat for mold and algae to grow. And you can see from this graph here that so the red line is an EPS insulation, the blue line is a wood fiber, and every time there's an upward step, that's when there's condensation on the outside surface. That's when there's the opportunity for mold and algae to grow. And you can see on common systems like EPS, there is a much higher likelihood of condensation and algae forming on the top surface. What that results in are buildings which typically on the south and west elevations are very nice, but on the north and east elevations can get a very green surface really quickly. And that is because they don't get sun, so they don't warm up. Very often they can be shaded by trees or other buildings. So you have to look at everything, not just the building itself and the fabric of the building, but everything that's around the building, everything that can potentially affect the ability of sunlight to get to the building. And to mitigate that, you can use an insulation which has a much higher density. And what that means is that it warms up much slower, but it also cools down much slower. So it's constantly warm. And if it's constantly warm, there's less chance of condensation forming on the surface. So again, there's a lot of studies being done on that. Again, have a look on the main STICO website. It'll give you a bit of information and background about how those processes can be avoided by using a natural material.